So here's question number 13 from section C on the combined gas laws. It says a sample of N2 occupies a volume of 250 milliliters at 25 degrees Celsius. What volume will it occupy at 95 degrees Celsius? So working with the combined gas law, there it is. A couple assumptions can always be made. The first one is, if something is constant, you can get rid of it in this equation. So for instance, if pressure was constant, we could get rid of it. Temperature constant, get rid of it, so on and so forth. Another good assumption that you can make is that if it's never mentioned, you can also assume that it's constant, meaning that you could get rid of it. So for instance, it mentions volume, it mentions temperature, but at no point does it mention pressure. So because of that, you're able to get rid of pressure altogether and get rid of a couple of those variables. So now we're just looking for V1, T1, V2, and T2. Let's read through that problem again, make sure we pull out all that information. Occupies a volume of 250 milliliters at 25 degrees Celsius. What volume will it occupy at? So that means volumes are unknown at 95 degrees Celsius. The most important thing when working with these problems is for volume and pressure, you can plug in any unit you want, but for temperature, you have to convert to Kelvin. So the first things first, let's go ahead and convert those to Kelvin. So we'll say 273.15 plus 25, we get 298.15 Kelvin. For T2, 273.15 plus 95, and we get 368.15 Kelvin. Now that we have our temperatures matching up, another important thing is that for our volumes, if we're plugging in milliliters for V1 or our initial volume, that means V2 will also come out as milliliters. So let's go ahead and plug it in. V1, 250 milliliters. T1 is 298. Make sure you plug in that Kelvin. V2 is our unknown. And T2, 368.15, again plugging in that Kelvin. Once we have it all set up, fractions can be a little bit intimidating, but we're going to go ahead and cross multiply. That's the easiest way to kind of solve for this. So right across, we're going to say V2 times 298.15 Kelvin equal to the other side, which is 250 milliliters times 368.15 Kelvin. Let's get V2 by itself, so we're going to go ahead and get rid of this 298.15 by dividing it. Whatever you do to one side, you've got to make sure to do to the other side. Equal and opposite to both sides. It cancels out on the one side. We're left with V2, so let's go ahead and plug it in and solve it. 250 times 368.15 divided by 298.15, and we get that the second volume, the final volume, is 308.70. For this, the units, again, we said from the beginning, since we were plugging in milliliters, that we would be getting milliliters out. The other way to know this is that our unit for temperature cancels, Kelvin to Kelvin, so the only unit left at the end of this is milliliters, giving our answer 308.70 milliliters.